Welcome to today's webinar entitled Roofing Care. My name is Billy Zadig, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon. Please visit our website at www.apa.org to register for upcoming events and to view archived webinars for continuing education credits found under the Continuous Learning tab. APA U is back, live in person, and coming to Providence, Rhode Island in September and Fort Worth, Texas in January of 2023. Information is available on the APA website under the Continuous Learning Series tab. Professional Continuing Education Certificates are being offered for today's program. AIA members who need their attendance reported to AIA should contact me at Billie, B-I-L-L-I-E, at apa.org. For those who indicated they wanted a certificate for this webinar and meet the requirements, the certificates will be sent later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. If you're just calling in, make sure to send me an email at billie@apa.org so I can send you a certificate if you would like one. The system only recognizes you if you log in. Before we get started, I'd like to give you some information about our speaker today. Bob Sanderson is a construction engineer, registered roof consultant, and registered exterior wall consultant at Design Collaborative with a passion for meticulous attention to detail and quality of construction documentation. Trained at Purdue University, Fort Wayne, he has 30-plus years of unique experience in design and construction administration of multi-million-dollar projects in higher education, multifamily, mixed use, and workplace markets, which led to high-performance solutions on every project he touches. He is registered through the International Institute of Building Enclosure Consultants, which certifies professionals with distinction among their peers for specializations in roofing, waterproofing, and exterior wall specification and design. Bob has been a member of the higher education team at Design Collaborative for over 5 years, where he has been involved in almost 200 projects. He has been highly influential on several major projects, including Indiana University South Bend North Side Hall renovation, Lincoln Financial Group Greensboro renovations, University of Notre Dame Joyce Center green roof. At this time, it's my pleasure to turn this over to Bob Sanderson. Bob, take it away.
Good afternoon, everyone, or good morning, depending on where you're at. Again, my name is Bob Sanderson. I'm a registered roof consultant and exterior wall consultant in the state of Indiana. And today I have the pleasure of speaking to you about roof care. So this particular slide sort of bullet points the types of items that we're going to be discussing: roof inspection, observation, evaluation, post-storm evaluations, common roofing irregularities, and how to look under a roofing system. So let's start out with a little bit of data. Roof leaks account for approximately 70% of construction litigation. This was documented by the AIA back in June of 2011. Roofing components and systems tend not to be as valued as much as other building amenities, unfortunately, such as exterior design and interior decor, because roofing is not typically associated with building revenue generating type things, and typically the primary human senses of vision, hearing, smell, taste, and touch, which are revenue generating type, have revenue generating type capabilities, unless of course it's a roof garden like we did at the University of Notre Dame. This type of approach can often lead to value engineering of the roof systems, or minimizing, excuse me, I flipped back a slide, or minimizing and neglecting roof maintenance. So very important data there. The EPA also knows some more data. The EPA found in a study conducted back in 1994 and 1998, out of approximately 100 randomly selected public buildings across 10 different climate zones, that 85% of buildings have been damaged by water during the life of the structure, and they estimate that 45% of buildings are still experiencing active leaking. Water leaking into buildings can lead to air quality control issues, as well as impact the health of building occupants. The NRCA estimates that for every 20-year warrantable roof that's designed and specified across all these climate zones, these roofs only last about 14 years because of maintenance neglect, which is highly unfortunate. So today we're going to talk about a few things to try to emphasize the importance of maintaining your roof. So first bullet point is roof inspections, observation, and evaluation. I like to recommend to clients that we typically do biannual inspections to coincide with winter to summer and summer to winter seasonal changes. At the very least, do one annual inspection. You know, roofs go through quite a bit of stress, thermal changes, a lot of temperature changes, a lot of wind events, a lot of precipitation type events. And so your roof, which is one of your primary lines of defense, is going to experience a lot of different, have a lot of different experiences. So it's very important that we get up there and we take a look to see how it's doing on, at least, like I said, an annual basis. So how do we go about that? And so I like to use this little diagram when I'm talking to facilities managers and things like that. The graphic here is color coded, so it sort of walks you through how to inspect a roof. Step one, you walk the perimeter of the roof to evaluate all the coping materials and specialty edge flashings and the seams. Step two, you're going to walk the roof to inspect your roof drains, your different types of curb penetrations, things like that. You're also going to just be looking at all the obstructions, and as you process, you're going to move on to step three, and where you're inspecting roof curbs, pitch pockets, flashing terminations for integrity. All these things are very important. And then I like to walk the entire roof in usually two different directions so that I can get a feel for how the roof membrane itself may be performing, to see if I can identify any holes, if I can detect any soft spots in the roof that might indicate that there's some moisture issues underneath the membrane. So again, looking at your roof drains, your roof curbs, your roof rail systems, your structural steel support systems, through wall scuppers, your coping conditions, all these are very important. And so we're also going to look at roof, you know, as we're walking the roof, you want to pay attention to your roof access in terms of roof hatches. You want to pay attention to your roof ladder systems that are accessing one level of a roof to another, your fall protection devices for OSHA compliance, rooftop communication systems, any lightning protection systems, expansion joint systems, and you also want to be observing your roof drainage patterns and things like that. There's lots of different softwares out there. We're not going to get into that today, but there is software out there that you can utilize to track these different types of components, types of repairs, or needed repairs that you need to make to these types of systems. Okay, first off, I want to encourage, I think I would be remiss if I didn't talk about fall protection a little bit. The photo that you see there with the roof hatch is actually a photo I took for one of our projects up in the northwest corner of Indiana. It's about an 8-story building. The roof hatch is very close to the parapet wall. You can see that poses a fall protection issue coming out of that roof hatch, especially if it's a wintertime condition. We ended up making some corrections to this particular detail. Structurally, we were not able to relocate the roof hatch, but we were able to incorporate some fall protection provisions in there to address this situation. You will notice there, this is an OSHA fact sheet. Whenever you're within 6 feet of the inside face of the parapet wall, you are required to have either be restrained with either the fall protection system. You must be in a restraint system, or you must be in a fall arrest type system as well. So then when you start to move a little bit farther away from the roof, 6 to 15 feet, there's different requirements there for the type of fall protection that you as a facility director must provide to assure the safety of the people that are on the roof doing maintenance to the rooftop equipment. And then usually the magic line is about 15 feet. Once you get beyond the 15 foot, you typically don't need a lot of fall protection, provided that the person's not going to be within those within less than 15 feet of the roof. So I would encourage you to look into this information a little bit more to make sure that you are properly protecting your employees or any service personnel that's going to be on the roof, to make sure that those zones of 0 to 15 feet away are properly accommodated for, so you can protect those people. And whenever we're doing new roof plans or design work, we're paying particular attention to this too, to make sure that we properly locate any rooftop equipment that's requiring service to be properly located from the parapet walls. All righty. So another component in terms of when you're looking at a roof system and you're evaluating the roof system, I like to look at, there's 4 different things I like to look at. It's called a water control layer, an air control layer, a vapor layer, and a thermal layer. The water control layer is the main line of defense against the against precipitation. Basically, you can see in this photo on the left that we've got ponding of water, and that water is being restricted in terms of flow to a roof drain. This can lead to various issues. It could be, you know, when you have ponding water like this, you can get the UV exposure on the roof is enhanced, and that can cause a breakdown in the roofing membrane seams. There are also, if the ponding water is not being restricted by the flow to the roof drains, there's a potential that we may have some deck deflection here. That could be an issue. But in any sense, the ponding water is not is an issue here, and it's either being restricted or there's some deflection in the deck that's causing that water not to make it to the roof drain. So this would definitely be an area of concern that we want to take a look at, because when you have ponding water like this, it can also impact your roofing termination details and the effectiveness of those details. The air control layer. The air control layer is, there's a couple things going on here when we're evaluating this. We're going to talk about this in a minute, but when we have winds moving across the roof, it creates different types of pressure differentials in terms of uplift on the roof. But we can also have, our roofing systems can also be impacted by air exfiltration through the building, whether that be through stack effect or just typical air leakage. We would want to evaluate that, because when we have air leakage or air exfiltration, whether that's through stack effect coming up into the underside of the roof system like that, often it's moisture laden air. And that moisture, if it were allowed to reach a dew point, can negatively impact the performance of the roofing materials. And in some cases, that can cause debonding issues. It can also cause some, lead to some billowing of the roof membrane, as it's showing here. But that's also sort of a component too of wind uplift when you see some billowing like this. But in any sense, when we're evaluating or assessing a roof, not only do we like to look at a roof from the roof side, but we also like to get underneath the roof if the ceilings are accessible, to sort of see how those perimeter joints are being treated. Are they sealed? Are the deck lap joints sealed? Because we can get air infiltration several ways into the underside of the deck, and it will impact the performance of your roofing system. All righty. All right, so the vapor control layer is another layer that I would like to talk about. Air, as it enters the roof system, will begin to cool. As that air molecule cools, its capacity to retain moisture in a gaseous state diminishes. As soon as the air molecule reaches about 100% relative humidity, it no longer has the ability to hold the moisture in a gaseous or vapor state, and will release the moisture in the form of a liquid. As mentioned, I'm sorry, change the slide on you. As mentioned, the moisture in the roof assembly can cause premature degradation in the form of trapped moisture. It can lead to adhesive result, debonding of adhesives and billing of the roof materials. And so the graphic on the right sort of, I think, is a good graphic. It sort of illustrates what happens to an air molecule as it moves from an area of high temperature to an area of low temperature. The molecule, when it's warm, is rather large and it has a certain amount of water vapor in it. As it begins to move to a region of colder, into a colder air mass, that same molecule is going to decrease in size, but the water vapor portion of it is going to be maintained constant. So as the air molecule decreases in size, its ability to hold that water in vapor form is going to diminish to a point where it hits a dew point, at which point that molecule is going to release that vapor in the form of a liquid or condensation. So when we're evaluating roof systems, it's important, if you don't have a roof vapor barrier, that you could potentially have some condensation issues in there. One of the questions you might ask is, when do I need a vapor barrier? Well, typically in climate zones, anything climate zone 4, 5, 6, 7, and 8, the NRCA came out with a recommendation that I typically like to follow. There's two components to that. If your average mean temperature is below 40 degrees Fahrenheit, that's one criterion determining whether you need a vapor barrier. Here in the state where I'm at, our average mean temperature is about 33 degrees Fahrenheit, so check one there. If your expected wintertime interior relative humidity design for the building is 45% or greater, that's check number 2. If you have both of those elements are applicable to your building, I would strongly recommend that you consider the use of a vapor barrier. If you're only checking one of those boxes, you can make a determination of whether or not you need a vapor barrier or not. Vapor barriers are always a good idea, but I also realize that value engineering and economics of projects are important. And so those are sort of the two criteria I use in determining whether or not a vapor barrier is required. Different types of buildings that require a vapor barrier is indoor pools that range between, they typically have interior relative humidity design of about 50 to 60% relative humidity. Hospitals range anywhere in the 40 to 60%. Competition arenas where you're going to have a lot of people in there, or theaters where it's going to generate a lot of moisture-laden air. Those are type of places that you would want to consider. I know we've re-roofed several basketball arenas, and we've always put vapor barriers on them. The other thing you might want to consider, well, the building may not, in the end, it may have a relatively low interior relative humidity design, but construction moisture could be an issue, so you might want to consider use of a vapor barrier just to offset construction moisture. So the other thing is the thermal control layers. There's different ways of heat transfer in a building, and convection, conduction, radiation. Conduction is our most common, where heat is transmitted through collisions between neighboring atoms or molecules and building materials. Conduction is dependent on temperature gradient, its material type, and length of travel. Once a temperature equilibrium nears, conductance will slow, then stop once temperature equilibrium is released. And so the detail on the left is becoming more and more common to maintain the thermal barrier, not only at the roof, but at the exterior wall, but tying those two components together and maintaining a constant thermal barrier. So these are other things that we're going to be paying attention to when we're doing roof assessments. And typically we'll be asking quite often, the owners for drawings and things so we can analyze the wall sections and the details. The conductance is our primary thing that we're going to be looking at on buildings. Post-storm evaluations. You might ask, when should I be, in addition to the annual inspection or biannual inspections, when should I be doing inspection? I would strongly encourage that if you ever have what's called a derecho, in a derecho, basically it's a band of storms that are rapidly moving. Or you might hear them often referred to as a squall line, but they usually have winds in excess of 58 miles per hour. The storm usually covers an area of about 240 miles. They're similar to tornadoes, but the damage is very linear, whereas and directional, whereas a tornado, the damage pattern is often circular. And so in our area, we've had, in this part of the state, we've had, in the state of Indiana, we've had 3 Dracos probably in the last 15 years, and we just recently had one. You can see on the graphic on the left, we just recently had one on June 13th of 2022, caused quite a bit of damage, especially on the southwest side of Fort Wayne. And we had a lot of people without power and a lot of street closures for several weeks. And so tornadoes, on the right, for a right-hand graphic, usually 65 to 85 miles per hour, you're going to see minor damage to buildings and trees. Winds 86 to 100 miles per hour, you're going to see major damage to roofs and building structures. And then when you get it to like an EF2, buildings down, you're going to see extensive damage, down trees, a lot of building damage. So you can use that sort of a guideline to, hey, I probably should get up there and check my roof. The graphic on the bottom right sort of shows you how wind moves across the structure. On the windward side coming in from the left, the roof is usually broken up into what we call zones 1, 2, and 3, with zones 1 being the corners of your building, zone 2 being the perimeter of your building, and misstated that. Zone 1 is the field of your building, zone 2 is the perimeter of your building, and zone 3 is the corner of your buildings. And your wind pressures are going to be the greatest in zones 2 and 3. That's where most of your uplift is going to occur. And then as the wind lifts up over the building and comes back down on the leeward side, it's going to re-engage zones 2 and 3 again. And so most of your uplift, those perimeter and corner conditions, where during a roof inspection is where we're going to be paying particular attention to make sure that your perimeter edge metals are properly secured, your roof systems are properly secured, because if we lose the roof, it's usually going to be in those regions. So we need to make sure that they are properly anchored and properly performing. Okay, hail events. I think whenever you have a hail event, you definitely want to be getting up on your roofs and looking at your roofs. You can see here the moderate hail region, the gray areas, and then we have the sort of the teal area, if you will. That's the severe hail region, and then the darker blue or blue-gray area is or the very dark teal area. That's your very severe hail region or tornado alley. Hail, typically people ask me what size hail should I be worried about. Well, anything, I think what I like to use as a rule of thumb is half-inch hail. Hail this size has the potential to cause damage. Damage may be minor, however, it warrants taking a walk around the building to scout for damage. 3/4 to an inch hail this size will generally cause roof damage and condensed sheet metal fabrications. We'll look at that here soon. And hail above 1 3/4 inch to 4.5 inches, it's potential for substantial damage, possibly compromising the weatherability of the building enclosure. Whenever you're designing the new roof, I would strongly encourage you to consider the use of cover boards. They're not required in all applications or for warranty purposes. You can still get 20-year warranties without a cover board. However, the cover board, as seen in the upper right-hand corner, it will help distribute that energy on a hail strike and protect the underlying insulation boards and the insulation facers. And so whenever you have a hail event and you don't have a cover board, the possibility for damage to the roof membrane and the underlying insulation is far greater compared to if you do have a cover board. That cover board will help distribute that energy horizontally and protect the underlying roofing materials. You still may need some roof membrane repair, but it does go a long way to distributing that force. All right, roofing irregularities by roofing systems. Everybody out there probably has different types of roof systems. We're going to talk about a couple different roof systems here. We're going to start out with modified roofs. Modified roofs, there's different types. There's APP modified roofing systems, or SPS modified roofing systems. APP is atactic polypropylene. It's more of a plastic type asphalt sheet. The bitumen modified is modified with plastic. Can typically be torch applied, heat welded, or self-adhered. It's a little more rigid than APP is a little more rigid than the SPS sheets. They do have a fiberglass reinforcement in them in terms of embedded in the bitumen. The SPS is a styrene, butadiene styrene. It's also, the bitumen is made with, it's more of a rubber composition. It's more elastic. It's typically more what I would specify. It's just a little more flexible than the APP. It can be heat welded, hot mopped, cold applied with cold applied adhesives or self-adhering. It's also reinforced with a fiberglass, which increases its tear resistance. One thing about modifieds is that there's redundancy usually with a base sheet and a cap sheet, and just performs really nicely. And so let's look at some issues with modifieds when we're looking at roofing systems. The hail damage, you can see hail damage on the left-hand side. The hail will displace the granules in the cap sheet, which can expose the underlying bitumen. This causes the bitumen to be more susceptible to UV degradation, which can in turn shorten the life of the modified cap sheet. The middle pictures, the two middle pictures are actually what we call blisters. And that's basically, there's water intrusion through possibly the sealant joints in the limestone caps, or could be a failure in the termination. The lower picture, you'll see there's some brick that's in need of masonry restoration. There's so much moisture there that it's caused falling of the brick, mortar to fall out, which is creating direct pathways into the back of the brick. And when I looked at this particular building, I noticed there was no through-wall masonry flashings. So the blister you actually see in the bottom photo is not only moisture in there, but it's actually brick that is spalled behind the modified base flashing sheet and is forcing that modified sheet to debond. And so there's definitely some issues here that are requiring repair, not only to the roofing system, but to the masonry walls and potentially the limestone cap sheets. The pictures on the right are additional illustrations of how parapet walls, you got the one is causing a lot of efflorescence, which is obviously impacting the modified base flashing sheet terminations. So these are some issues here that we would be looking for as part of a roof investigation. Here is some seam failures. Those are called by thermal expansion and contraction, building stresses, UV exposure, aging and fatigue. We also have some themes. We also have some other types of seam failures that have experienced some tear. These have to be dealt with. And a lot of you probably noticed this membrane fatigue or aging. This is pretty common. Asphalt is a complex mixture of carbon atoms and hydrocarbon atoms, and as it goes through weathering, it will break down, and as a result of UV absorption from the sun. And this UV absorption will cause molecular vibrations and debonding, which presents as cracking or alligatoring of the asphalt. And so and then another factor is we can get aging of the modified sheet is, where we have oozing of molecules, if you will, the molecular oils from the asphalt, which act as plasticizers, which are designed to improve the flexibility of the roofing material. So whenever you see this, is a good indication that your roof is reaching the end of its useful life. Another thing we want to look at is low roof to wall flashing conditions. Here, these are door sill and louver sill conditions, which are too low to the roof. The NRCA recommends that whenever you have these types of conditions, they should be at least 8 inches above the roof line. Obviously, these are not. So these would be areas of concern for us that we would want to pay particular attention to see how they're performing and what kind of repairs need to be made to them. Continuing on with the modified bitumen, you can see on the upper picture, I took this picture, the roof drain bowl is completely missing. And in the bottom picture, the lead flashing sheets that are used to help with the termination of the modified bitumen sheets at the roof drain detail have been compromised and have actually failed. which is causing some moisture infiltration points. So these are the types of things, again, that we would look for as part of a roofing inspection. Okay, EPDM. Some of you might have EPDM roofs. It's an ethylene propylene dine membrane. You know, it's made with petroleum and gas, colorless gas, and then it's synthetic rubber consisting of carbon and hydrogen. You know, typically EPDM roofs are very stable, heat resistant. They handle expansion and contraction very well. EPDM forms very well to complex shapes, but they are susceptible to UV shrinkage, oils and greases, and puncture. And so you can get EPDM reinforced if you got a mechanically attached roofing system. But let's look at some of the things that I've come across over the years. The two pictures on the left, one's a little bit, it's taken a little bit further back, and the bottom left is where we actually had a hole in the roof membrane. This was caused by someone actually dropping something on the roof. I have also found that sometimes you'll find bullets embedded in roof membranes. You know, people, you know, 4th of July celebrations will fire off firearms, and those bullets have to come down someplace. And sometimes we'll find bullets that are sticking partially out of roof membranes that will require a repair. The one in the picture in the middle was actually a seam failure. It was a white on black EPDM roof that required a seam repair. That was, you know, those little pinholes like that can cause issues. And then seam failure on the right is actually an EPDM roof that had been down over 20 years and essentially simply was the end of its life and was in need of repair. Okay, here's some issues showing some blistering on the left. This was interesting, if you recall earlier, we talked about billowing of the roof membrane, possibly through air exfiltration into the underside of the roof membrane. This actually was a little bit different. These roofing materials actually got caught unprotected in a rainstorm, and it caused the roofing materials to, as they dried, the facers on them began to constrict, and it caused the insulation boards to bow, if you will, and it actually caused a debonding of the adhesives between the insulation layers, as you can see. But it presented as billowing, so we were very concerned. You know, was it wind uplift? Was it you know, pressure from inside the building that was causing this? But we went through some extensive evaluation and found out that we had an issue with actual insulation boards getting wet or left unprotected during a storm. And so that was one of the things we took there. But you can see we took some test cores to determine exactly what happened. Shrinkage is they break down. The one in the lower right is a breakdown of the rubber due to years of UV exposure, resulting in flashings pulling away from the parapet walls. This can also happen at drains, inside corners, as it shows here. It can also be a result of improper support of the EPDM at an angle change with you're not using the proper materials to reinforce the backside of that EPDM as it makes that transition from a horizontal to a vertical. And then expansion and contraction can also be an issue. The upper, so if you see what this is also referred to as tenting sometimes, if you see this, it's an indication that your roof is reaching the end of its useful life. If you see the off-gassing in the upper right-hand corner, that sometimes is a result of the solvent they use to bond the adhesives not properly flashing off before they apply the EPDM. Sometimes you'll get this, it'll result in vapor being trapped behind the EPDM, and these types of blisters may subside over time. However, the result may be debonding of the EPDM in that location, which may raise concern about the susceptibility of the roof membrane to wind uplift forces. Here's some other issues that I've discovered over time in terms of roof to curb issues, some tears, other equipment curb issues, and pitch pockets. Pitch pockets are notorious for being a very weak component on the roof. They're not my favorite. There's other means to handle this type of transition of MEP infrastructure from the roof to the, or I'm sorry, from the interior to the roof side. So, but they are areas of concern that we need to pay attention to. Again, more EPDM. These are some pictures I took. You can see we have a seam failure at the roof drain. We have vegetation restricting the storm flow into the roof drain. And then we have a seam failure on the right-hand side, just above a scupper. Take note of that scupper. That scupper is very small. Most building codes require the scuppers to be a minimum of 4 inches in each direction. That scupper is not, making it very difficult to roof and properly terminate. The one in the picture in the middle is actually a roof drain in there, but it's it's covered over by vegetation. Okay. EPDM, again, this is some photos I took of a project. You can see we got very low clearances. There's really no way to roof underneath that ductwork if we ever need to. The chart on the right gives you some rules of thumb on the width of your, if you have a roofing component that has a certain width, it gives you some minimum clearances above the surface of the roof to allow for proper inspection, repair, or roof replacement. As you can see, to do any re-roofing here, we would essentially need to take that component off the roof to allow for any re-roofing, which could impact the function of the building or activities within the building. Thermoplastic roofs. Thermoplastic roofs, we have different types here. We have key thermoplastic, which is ketone ethylene ester. That was developed by DuPont. It's very UV stable, excellent weatherability, long-term flexibility, excellent chemical resistance. We have TPO roofs, which are thermoplastic polyolefin, polypropylene. It's also made, it's got an ethylene propylene, which is a rubber that gets built into it, and then it also has a lot of fillers. TPO provides good UV and heat stabilization. We'll talk a little bit more about that. And then we have PVC, which is polyvinyl chloride. Typically, it's made with salt water, natural gas, UV light process, PVC resins, and plasticizers that create a flexible sheet. All these sheets are reinforced with either polyester or fiberglass scrim. Typically, the polyester is a much stronger reinforcement than the fiberglass. It's much better in terms of tear strength and puncture resistance. But you might have one of these types of roofs. So again, the modified roofs have redundancy built into them, EPDM, and then these thermoplastic roofs are single ply systems. And so it's very important that they are the main line of defense without any backup. So it's very important that we inspect these. How do these get applied? They often get applied. There's different ways, but the most popular way, you see a lot of these roofs put down. The roof, the field of the roof is put down with either with an adhesive. It can be also mechanically attached. It can also be ballasted. And then in all cases, we would want to heat weld these seams. And so here are some examples of what we call cold welds. With the heat welded seams, you can see the one in the middle is actually a TPO seam that I was able to locate a cold weld. And these cold welds can weaken seam integrity. It provides a pathway for water infiltration or freeze thaw action that may further weaken the seam. The heat welded seams, they're chemically, when you heat weld, it creates a chemical bond in the seam. And so it's when you're dealing with thermoplastics, it's very important that you analyze the mill thickness of the thermoplastic above and below the scrim. That's important when you're specifying thermoplastics. And the seam on the right is a pinch seam or a blister. It too can provide a pathway, but more importantly, the seam is not, if there's not full contact there across the full width of the weld, which is typically about 1.5 inches wide. And so you can see there, it just creates a weak point in the seam, and they're going to need to come back and patch that over to maintain the integrity of that. The picture on the left is actually a cut. It's a cut in the edge of the factory edge, and that's important to be repaired because it actually will expose the reinforcement, and it could possibly lead to wicking of moisture into the reinforcement in between the plies of the thermoplastic sheet. So that would be an area that we would want to pay attention to. Picture in the middle is one I took where the roofer did not complete the termination, did not provide a clamping ring or any water block in terms of creating a compression seal where this thermoplastic boot makes the transition to the conduit or the piping there. And so, and then the picture on the right, whenever I'm inspecting a roof, I actually like to get down on my back and look up underneath the roof curb, if you will, where the piece of mechanical equipment is overlapping the curb. In this particular case, you can see the little arrow is pointing to where someone drove a screw, pulled the screw out, and then reset the screw. It left a little hole right there. May not be a big deal down in the southern parts of the country where you're just typically dealing with rain, but in northern regions where we're dealing with snow and snowdrift, if we had snow pile up against this curb and it goes through a little bit of thaw on a warmer day and then refreezes, that potential moisture could end up behind the roof membrane and cause a problem. Improper installation of induction weld plates. Induction weld is a chemically fused connection between the top of a seam fastening plate that's been factory coated with an adhesive formulation and the underside of the thermoplastic membrane. That was what the picture on the left shows. You can also see where they had either they had improper settings on the induction welder, or the plates themselves when they secured the insulation boards were slightly tipped, so that when they went to chemically fuse the top of the fastener plate and the underside of the thermoplastic sheet, it actually sort of pulled the edge of the fastener plate up into the membrane, which further weakens that membrane. And so that was an issue that we actually had to involve the roof membrane manufacturer from a warranty standpoint to make take some corrective actions to repair those conditions. The one in the middle, the fastener plate is too close to the edge. That's hard to predict when you're fastening insulation boards, as to where that seam between thermoplastic sheets is going to end up. So what we ended up doing is providing a cover patch there to help reinforce that, so that we didn't have that direct conflict between the edge of the plate and the heat welded seam. And then the picture on the right, I usually like to look at these to see what kind of when we have storm drainage from one roof level to another, I'll typically put a sacrificial membrane there to help disperse that storm water across the lower thermoplastic sheet. Especially in this picture, you can see there's a seam right there. So we want to disperse that storm water in a way that it's not creating direct discharge, especially right across that seam that might eventually become a problem. Okay. So everybody's probably always thinking, TPO, in terms of TPO or PVC, chemical resistance guide. This was a nice little guide I found online a while back. It's published by GAF. It sort of gives you a breakdown of different TPOs and PVC roof membranes and their grade in terms of how they perform. I will tell you that TPOs will tend to do better than PVC. But TPOs also are known to certain types of sheets, or depending on how they're manufactured. If they have prolonged exposure to kitchen greases or oils, they may have a tendency to stain, absorb those materials and end up staining. PVC, they have a chloride content to them that helps them with that helps those sheets with chemical resistance. But again, in both cases, I tend to work with the manufacturers to make sure that if I'm using a PVC or TPO sheet and I'm going to have exposure to kitchen greases, oils, vegetable fats, animal fats, what can we do to collect that material, and what can we do to provide sacrificial membranes or protect the primary roof sheet? So I show you these to indicate that it is important that you compensate for that in your design. And whenever we're doing inspections, I'll be taking a look at this too. We typically orientate the sacrificial membranes downwind of where the discharge might be. You can see in the middle photo here, this was a picture I did I was inspecting a building, and this was their solution to capture the kitchen greases and oils. They actually built a containment system right around the base of the curb there to collect any oils and greases, and then their maintenance people would go up there and clean it up. These are some roof drain and through wall scupper issues. And the roof drain on the On the left there, you can see the hole in the membrane is too small. And typically, the hole in that membrane needs to be equal to about the inside diameter of the pipe plus about ½ inch. And then you can see the through wall scupper on the right is got a little bit of a seam issue there. We're going to transition to asphalt shingles real quick in case you have a building that has asphalt shingles. Typically, that deals with underlayments, ice and water shield, those types of things. I'm going to speed up a little bit here since I'm running short on time. Hail damage, you can see the types of hail damage here that's presenting on the roof. Again, it's creating granular displacement, exposure of the asphalt. This will weaken or shorten the life of your asphalt system. A lot of times when we're dealing with hail damage, it'll present on the sheet metal enclosures or the sheet metal fabrications on the roof or on fins of the AC units. And a lot of times you can tell which direction the hail damage is coming from. Wind damage. Sometimes you come out after a strong wind event, you come outside and you may not even notice that you have wind damage. But when you start getting up on the roof, you'll realize that the seals of your shingles are broken. And a lot of times when we start marking it off with chalk, we can actually determine the pattern of wind or from which way the wind was coming, and we can sort of see how the wind has moved across the roof. Sometimes you'll have wind damage on one side of the roof and not the other. This is more wind, the same two photos I just showed you, except for I added one on the right. This was a photo I recently took on a building where they were experiencing wind damage. And so it presents a little bit differently in all cases, but it's very important that you take a look at that. Nail pops, improper ventilation, curling of shingles. A lot of times this has to do with ventilation issues on your roof. And that's the one thing I would take a look at. So I would do that in terms of looking at your ventilation issues on your roof to see what kind of things are going on there. Again, discharge issues. You're going to see on the one in the middle, pipe flashings, where the boot is starting to tear, and that's because of UV degradation, and it's losing its friction fit to the pipe, and that can create a source of water infiltration. Algae growth. You've probably all seen this on houses. An increase. A lot of shingles, they're manufactured a lot of times now with limestone fillers in the manufacturing of the asphalt sheet to control cost. Limestone fillers support algae growth. They tend to hold moisture and support that algae growth. A lot of times shingles are made with granules that have a mineral core, and the granules have a ceramic coating on them and a copper also built into them, a copper coating. And as the shingles go along, this copper is slowly released to help wash the roof. But over time, as that copper content of the minerals diminishes, you'll start to see this algae set in. But you're going to notice that just downstream from the sheet metal flashings, that it's still well protected because there's probably some zinc or something in that sheet metal that's being released, and that's washing the roof. We're also going to pay attention to roof to wall terminations to make sure that we don't have any issues there. Ice damming. We typically have insulate. It's probably a good sign that there's some ventilation issues and lack of insulation at these conditions here, where you have warmer air coming up into the attic. It melts the roof. That water then moves down, and when it re-engages a colder surface in the eaves, it refreezes. And then it starts to form. It starts to act as a dam, and then you'll get these ice formations at your eaves. So this is a good indication that you probably have some ventilation issues and possibly some insulation issues at your perimeter. If you have a metal roof, we'll look at this real quick. Oil canning. It's a very natural thing. It's a visible waviness in the flat areas of the metal roof and metal wall panels. It's referred to as elastic buckling. It's also stress wrinkling. It can occur in any type of metal: steel, aluminum, zinc, or copper. We can compensate for oil canning, by specifying different types of gauge of metal, use of rib stiffeners, panel profile in terms of length and width, and we can also look at finishes to conceal the effects of oil canning. Here's some corrosion. This is probably a zinc roof membrane, galvalume type roof, and we probably have copper coils that are just charging that traces of copper onto the roof, and that's creating corrosion. and that's leading to some issues here. Probably the big thing they could have done here was extend those PVC pipes all the way down to the roof edge, and then that probably would have prevented this corrosion that you're currently seeing. Here's some different information in terms of anode and cathodes. You know, one metal acting as the anode, the other acting as the cathode, and the different types, you know, the galvanic chart in terms of what metals play nice with each other and which ones don't. There's different ways we can deal with corrosion in terms of protecting the anode from corroding. You know, we can use insulators, we can use two metals that are very compatible with one another. We can also minimize the electrode, which is needed to cause corrosion. In this case, water. We can isolate it one metal or the other, or we can put a coating on either the anode or the cathode metal to protect the metal. But you can see here, this chart is a very nice chart that shows you how the different metals react with one another. And in that previous slide, we definitely had some corrosion there that was causing some issues, and that was because we had incompatible metals interacting on that roof. We're also on a metal roof, we're going to look at the compression seals as panels transition from one to the other. Could be a breakdown in the butyl tape in that compression seal that might be causing some leaking. You can see on the one on the right there where they're having some issues with the compression seals, so they've come back in with the coating to try to fix that. Other issues we might have is obviously the penetration is right on the standing seam. Probably would not have allowed that, probably would have had them relocate that so that it didn't occur right in the primary area where our weather protection is most critical, which is in the standing seam. You can also see we have some issues with the termination at the ridge vent, and on the right we've got some caulking and fading issues, which are chalking and fading issues, which are impacted by UV, temperature, moisture, finished pigments, and different types of resins. So all these things would be things that we would look at in terms of our roof inspections. And then the last thing real quick, I think I still have a little bit of time. I do. So different ways we can look at evaluating. Once we know we have some issues or we think we have some issues, we can evaluate using different techniques. This is to look underneath the roof system. We can do some FLIR imaging here, which is looking at temperature differentials. This type of equipment can be very sensitive, so sometimes, even though when you're looking at a FLIR image, what happens is in daytime temperatures, if there's moisture underneath the roof membrane, as your daytime temperatures rise, the water or moisture underneath will hold that temperature. So as it cools at nighttime, materials that hold moisture won't cool off as fast as materials that aren't wet or holding moisture. So it creates a heat signature. And on the right here, you can see the yellow and the oranges. Those are typically indicating areas where there's potential moisture. Your blues or purples are areas where they're not holding moisture or those materials are cooler. This doesn't necessarily mean it's wet under there. It could just be a temperature differential. We still need to go in and do some coring, some invasive coring to confirm whether or not moisture is there. But the person doing this did identify this as an area of concern that requires further investigation. Again, this type of investigation is looking at a thermal temperature gradient. We can also do electric capacitive impeding test. It sends an electric current into the roof and it's based on the material's ability to store that electrical energy. If there's a moisture signature there within the roof system, the information that comes back to the device will provide higher readings than a dry material would. This range, you can usually do this over about a 4 to 6 inch range in terms of depth. You can see the dry areas are highlighted by yellow. It's a little bit different than the infrared. The probability of dampness is usually your light orange to red, and then your likely wet areas are highlighted by your green. Again, we want to follow this up with invasive investigation to see, but again, this is using an electric transmitter, if you will, to send the signal through the roof, and then that signature is bounced back to the device and will give you information in regards to whether moisture is present or not. Then we have low voltage GLD testing. Basically, this is we provide a conductive wire loop atop the roof where the roof is being tested. We have a lead that is connected to the structural deck, and then we have another lead that's attached to the top. and typically this needs to be a wet roof for this to work. And then if there's any breaches in the roof membrane system, it actually creates a closed circuit between the electrode that's attached on the other side of the deck and then the electrode that's on the top. It'll close that circuit, and you can actually pinpoint with relatively good accuracy where the roof leak is. Now, this is somewhat specialized testing per ASTM 7877, and so you usually want to hire a testing service to do this type of testing, but this is another way to get a good evaluation of what's happening underneath if there's a roof leak on your roof. And then we have high voltage testing, where again, sort of a similar concept, except for we're using a pulse generators connected to the structural deck. We have a lead, it requires the membrane to be dry, and then the operator is going to sweep these brush electrodes across the roof. And then again, if there's a hole there, it'll create a closed circuit between the electrode connected to the underside of the deck and electrode to the top of the deck. And we're almost done here. Again, as I mentioned before, we want to do invasive testing on all this to make sure that if we're detecting a moisture signature underneath, that we get in there and we just, we validate what we're seeing with the invasive or the non-invasive testing or the non-destructive testing. And the picture on the left, this was one we did on a project, and actually this was a existing metal roof that was infilled with insulation boards, cover board, and Epdm that was failing. And when we opened it up, we actually found heavy corrosion in the standing seam portion of the metal roof. The one on the right is an old modified built-up roof that we exposed the precast tees, the top of the precast tees, and there was fiberglass insulation there that had been wet for long periods of time, and essentially it turned into powder. So in all instances, it's very important to evaluate your roof. And I would suggest if anybody's not currently working with a roofer, a qualified roofer, you can go onto NRCA's website. I got a web link there for you that you can make contact with, and they'll find a roofer in your area that can come out and start assisting you with evaluations of your roof. Again, it's very important that we maintain these roofs and we do our due diligence to keep them performing well beyond that 14-year estimated period that a typical 20-year warranted roof performs. So with that, Billy, I'll turn it back over to you.
Okay, thank you, Bob. We have lots of questions that we will not be able to get to all of the questions, so I'll let everybody know that Bob will be reaching out to you to answer your question through email. We do have time for a couple, so let's get started. On your initial slide, you mentioned something called a sleeper. Would you define what a sleeper is?
I'm sorry, can you repeat that?
On one of your initial slides, you labeled it as a sleeper. Would you define what a sleeper is?
A sleeper? I'm trying to go back to that slide to see if I can find out what you were referring to. Not sure what you're referring to there.
Okay, I'll send you the.
Because I'm not sure I understand what the question is.
I sure will. So on our next question is, how do patches affect the useful life expectancy of a roof? More specifically, a new roof that has dozens of round roof patches before substantial completion.
Again, I'm not hearing you very well for some reason. Can you repeat that?
How do patches affect the useful life expectancy of a roof? More specifically, a new roof that has dozens of round roof patches before substantial completion.
Well, I'd be very curious to know why it has a bunch of patches. What's causing that? It might be, I don't know if there was some damage caused to the roof, by other trades being on the roof, and it caused damage. And then, all those holes needed to be patched. A lot of times those patches are patched in compliance with roofing membrane manufacturers' recommendations or recommended details, and it will be included in the warranty. I'd be curious to see, what caused those patches, did they occur during installation, or was it other trades, not properly protecting the roof during the installation of their materials that caused that damage? But in all cases, depending on the type of damage or the type of patches we're talking about, they will be included within the warranty. I guess I would love to see some pictures on that, or get a some different information just to see exactly what they're referring to.
Okay, thank you. Well, we're at the top of the hour, so I want to say, Bob, thank you so much for a very informative webinar today. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much for being with us today.
Thank you.